In this video, we're going to look at how to create a buffer, right? And what the initial values would be for weak acid buffers and their conjugate base using salts. Okay, so we're going to go ahead and try to add this conjugate base in directly by using the conjugate base salt. So we're going to add some weak acid and some conjugate base in directly, and we want to try to get these initial values, and then you guys will solve the ice table from there. So in the first possible way, what if they give you a solution of the weak acid, and then they give you the solid of the conjugate base, the salt? So again, we have the weak acid and the conjugate base, salt. So in this example, we have acetic acid, and so the conjugate base would be acetate ion. And so we need a little bit of both. But in this case, we need the concentrations of both, but we're adding grams of sodium acetate. So if we need in order to set up that table, we need the concentration of the acetic acid, and we need the concentration of the acetate ion. Okay. So in this case, we have 100 milliliters of 0.1 molar acetic acid, and then we're going to add in 0.80 grams of sodium acetate directly into that 100 milliliters. Oftentimes in the College Board questions, they'll say that the volume of the solid that was added is negligible. So once you mix these two things together, the volume is going to be 100 milliliters in this case. We don't really worry about the volume that 0.8 grams contributes. So if we're going to take a look at this, then what we need to know is what's the molarity of the acetic acid and what's the molarity of the acetate ion. Well, the molarity of the acetic acid, since the volume is not changing when we add in the sodium acetate solid, then the molarity of this 100 milliliters, the 100 milliliters isn't changing. So the molarity of the acetic acid isn't changing. So we actually do know the concentration of the acetic acid out of the gate. But what we don't know is the molarity of the acetate ion here. So we have to figure that out. So how do you figure that out? Well, we take 0.80 grams of sodium acetate times, well, sodium acetate has a molar mass of 82 grams per mole. So that's 1 mole of sodium acetate for every 82 grams. And that gives us a 0.009756 moles of sodium acetate. Well, how many acetates do we get for every sodium acetate? Well, it's just one. So that means we have 0.009756 moles of that acetate ion. Well, that's moles, that's not molarity. So what are we adding this into? What's the volume when we add this in? Well, it's going into this solution. It's going into the 100 milliliters. So we need to divide that, moles by liters, 0.100 liters, and this will give us our molarity to be 0.098 molar acetate, if I round that out. So these are the two values I'm going to plug into my ice table. For my initial values, I'm going to plug in 0.10 molar acetic acid and 0.098 molar acetate ion. And of course, in that case, the hydronium ion concentration is just starting off at 0. Okay, in this next possible way, we are going to create a buffer using the same stuff, but instead of being given solid sodium acetate, you're being given a solution of sodium acetate. This is a little bit trickier because when you mix these two things together, this volume is not negligible. I mean, you're adding 50 milliliters to 50 milliliters. You have to take that into account. And when this occurs, when you're mixing two solutions like this, you have to be careful. So what you need to do is you need to get the moles of each thing and then divide that by the new volume. So there's a couple of ways that you can do that. You can skip right past the calculating moles, and when you mix things, you can use concentration 1, volume 1 equals concentration 2, volume 2. So this is the dilution equation. You might have seen it as M1V1 equals M2V2. You can think of it as, the concentration in volume 1s as before you mix, and the concentration in volume 2s as after you mix. So concentration 1, let's look at the acetic acid first. Concentration 1 is 0.10 molar. The volume is 50 milliliters. Concentration 2, or the mixed concentration, once you put those together, and the one we need, we don't know, not yet. And the new volume, well, what's the new volume going to be when you mix? Well, the new volume is going to be the 50 plus the 50, so that's 100 milliliters, or 0.100 liters. So if I were to solve for that new concentration, I would get a concentration of 0.050 molar acetic acid. And that can get plugged, C2H3O2, and that can get plugged right into my initial value for my weak acid. Well, that's the concentration of the weak acid. What about the concentration of the conjugate base? Well, in this case, you have to do the same thing, but it also does happen to be the same here, but you want to make sure you redo that. So the concentration of the mixed value of that is 0.050 molar. Sodium acetate, we get 1 acetate ion for every sodium acetate. So here are the two values. I plug into my HA and my A-, so my weak acid and my conjugate base. I can plug those right into the initial values. The hydronium ion concentration is going to be 0 to start. And then you can solve your ice table from there.